Okay, if the point person has passed out the packets, you should be looking at Unit 3, Lesson 7, Ready, Set, Go. The ready is going to take us back through our exterior angle relationships, and we just need to find the value of x. The measurements to remember are that all of the angles in a triangle add up to 180, and that the two angles that make a line add up to 180, so it would be helpful to have your calculators for this one. If we look at the two angles we know, 85 and 23, those are going to add up to 108. That'll leave us 72 degrees for this last angle, but if you remember your property, the exterior angle has to equal the sum of the interiors. So we can jump straight to x equals 108 degrees, or if you want to, you can use the process we used to proof it and say if this is 108, that leaves 72 degrees in my triangle, and then I use my 72 degree angle, subtract that from 180 to get the 108 on the outside. That relationship can also be used here. If you want to use the 135 to find this angle and then these two to find that one, that's fine. I'm emphasizing that the remote interior angles add up to the exterior. So x plus 87 needs to add up to 135. If I subtract 87 from both sides, we'd find that the missing part is 48. And we label x equals 48 degrees as our answer. This approach here, I know, might seem less direct than going from 135 here to 45 here and then adding the 45 to the 87, but it's going to be helpful when you get to situations like this because it emphasizes the relationship between this angle, and the exterior angle, that these two add up to this. So in this situation, I can write the whole equation. I can say this bottom angle, 2x plus 10, when added to this top angle, 6x minus 10, have to sum to 120 degrees. And now I'm back in algebra class. I'm collecting my like terms. I have a 2x that's positive, a 6x that's positive, for a total of 8x. And then I have a 10 and a negative 10, and those are going to add up to 0. So plus 0. And that has to equal the 120 on the other side. So that just becomes 8x equals 120. And I can find the value of x by figuring out what number goes into 128 times. Dividing both sides by 8. Find that x is 15. At this point, it's probably helpful to read the actual instructions. In addition to finding the value of x, they will also want to know the measure of the missing angles. To this point, x has been the missing angle. But in this case, the missing angles were in terms of x. So x equals 15 is part of my answer. But I then need to go back and plug it in. This becomes 2 times 15 plus 10, or 30 plus 10. So the missing angle here is 40 degrees. And up here, 6 times x minus 10. So 6 times 15 minus 10. 15 and 15 is 30, so that would be 3 30s. That's 90. Minus 10, 80 degrees is the missing angle there. Try that process again on number 4 and number 5, using the fact that the remote interior angles sum to the exterior. Pause the video and give that a try. For the second portion here, 6 through 10b, we're looking at two parallel lines, which we know are parallel because the arrow is noted there, and they've been cut by this, which is the transversal. And we need to name both the relationship and then what that means for the angles. So not only are they corresponding or alternate interior, but does that make them congruent, supplementary? What did we prove 2 days ago about that? So here's my two parallel lines cut by a transversal. Angle 2 and angle 6 are here. There's 2. And then here's 6. And I'm hesitant to put the line there unless I know they are congruent. But in this case, the relationship, this one's in the upper right-hand corner of that intersection. 6 is in the upper right-hand corner of this intersection. They are corresponding. And that means they are congruent. Because corresponding angles have exactly the same measure. It might be helpful at the very beginning to note two pairs of angles that are corresponding. Those are congruent. And then their vertical pairs have to be congruent to them. So all 4 of these angles are actually the same measure. And the same is true for the other 4 angles. This angle 1 here is supplementary to 2, but so is angle 4, and it's vertical to 1. So those have, whatever measure that is, I don't know, 100-something degrees. These 2 angles as well are going to be not only congruent to each other, but congruent to these here. So there's only 2 angle measures in the whole picture. So if we can name a relationship, they're either going to be congruent, they're exactly the same measure, or they'll be supplementary because they add up to 180. A black and a red add to 180. 2 and 8. Both of these, they're not corresponding. If I slid this intersection down, 2 doesn't land on 8. But both of these are outside of the parallel lines. So when you are outside of the parallel lines, those are exterior angles. And compared to the transversal, which is the line here, you'll notice they're on the same side of that transversal. They're both on this side of the transversal. So the relationship we would give is same side exterior. And what do we know about same side exterior? Well, one's the black and one's the red. If I slid 8 down onto 4, you could see that they would be supplementary. So 2 and 8 add up to 180 degrees. They're supplementary. Continue with 9 through 10b, identifying the relationships and then stating whether they're congruent or supplementary. Pause the video. When we get to the set portion here, we're going to talk about why vertical angles works. And we've proved this before, but again, our goal is to be able to follow students' proofs. So here's vertical angles, 1 and 3. And here are 2 students, student 1 and student 2. Both of them are going to try to show that 1 is congruent to 3 with a proof. When you read through a proof, every time you look at a piece, you need to go back to the picture and match it up. So if we look at student 1, they said measure of angle 1 plus measure of angle 2 is 180 because they're a linear pair. There's 1, there's 2. Sure enough, linear pair. And they said 3 and 2 add up to 180 because they're a linear pair, and I can see that in the picture as well. So check off each of these statements as we confirm them. So now they're saying that the measure of angle 1 plus 2, which we said was 180, and the measure of angle 3 plus 2, which we said was 180, are equal to each other. They claimed it's by substitution. It's because they're both equal to the same number, so we can set them equal to each other. So that makes sense. But if those 2 sums are equal and they both have an angle 2 in them, the angle 2's kind of have to balance out, which means the 1 and the 3 would also balance out, and that's their claim here. So measure of angle 1 must equal the measure of angle 3 by the subtraction property of equality. Just take measure of angle 2 away from both sides. You know you took the same amount away, so the same amount's left, and that shows the vertical angles are congruent. 1 and 3 were vertical angles. Student 2 reasoned differently. He's going to tell you ahead of time what she thinks she's going to show, and then she's going to show it to you. I know they're congruent because you can rotate angle 1 so it lands on angle 3. If you stop there, that's rubbish because you're just saying, well, 1's going to land on 3. Well, that's true if they're congruent. You're trying to show that they're congruent. Why? Why do you know that angle 1 will line up exactly on angle 3? That's the colon. Since the lines are straight, we know that it's a 180 degree angle. Sure, this line is 180 degrees, this line's 180 degrees. So rotating 180 degrees about the point of intersection will cause the lines to land back on themselves. Aha! If I take angle 1, this line right here, 180, lands it right here. And the red line over here, 180, lands it right here. And sure enough, angle 1 then lands right on top of angle 3. So rotating 180 about the midpoint causes the lines to land back on themselves, which confirms that the two angles are congruent. So we've analyzed both of the proofs. They both seem pretty straightforward. Let's see what the questions are. Which proof uses rigid transformations? That was clearly a rotation, a translation, or a reflection. Those are all rigid transformations. So that was student 2. What property of linear pairs, let's underline that word, linear pairs, does student 1 use? Let's go to the word linear pair in their proof. Because they are a linear pair. So what was happening because they were a linear pair? They were adding up to 180. Angles that add to 180 are supplementary. So linear pairs are supplementary, which means they add to 180. And then finally, which proof do you find easier to follow and why? Well, that's going to be up to you. You can answer that one based on your opinion. You can say student 1 or student 2, but you need to add a reason to it. You pause the video and write that down. And then question 12, what's the difference between a mathematical conjecture and a mathematical proof? This is an important vocab distinction. Conjecture is a guess about what is true. It's more than a guess. It's actually a proposal. I'm saying this might be true, but it doesn't have evidence. That's the key difference. No evidence yet. So we make conjectures and then we try to prove them. A proof uses evidence and logical reasoning to show a statement is true. So this is, I think it's a rhombus, and this is, it must be a rhombus because I can prove it has 4 congruent sides. Question 13 is going to do much the same thing, and I'd like you to try that process. Walk through each of these students' proofs about angle 3 and angle 6, which are alternate interior angles, being congruent. And they're going to try to show that alternate interior angles are congruent by showing that if these two lines are parallel, then 3 and 6 must be congruent. When you're done reading through their proofs, answer question 13. Pause the video. Finally, 14 and 15 want you to prove that alternate exterior angles formed by parallel lines cut with a transversal have to be congruent. So they've given you a pair of alternate exterior angles, exterior on the outside, alternate other side of the transversal, and you're trying to show that 2 and 7 are indeed congruent. I would encourage you to use a similar logic to what you saw in the previous. And I'd also encourage you to use a 2-column or a flowchart proof. If you're using a 2-column, it's going to go like this. You're going to have statement and reason. And remember, when you're trying to come up with a proof, you don't start by just writing, so I don't know, unless I've given information. I suppose I do. EF is parallel to CD. But you're trying to get at the end of this whole proof to this statement here. Angle 7 is congruent to angle 2. And you're going to need to use some sort of logic in between. So see if you can think about what do I have to use to prove these? Well, they give you a hint. You can use what we've already proved about corresponding angles. So start this one maybe by talking about an angle that the angle that corresponds to angle 2 and the fact that we've proved that to be congruent, and see if you can get from there to finishing with angle 2 and 7 are congruent. You can look back at the previous proofs if you think they're helpful. You've got a similar challenge down here. We're going to try to prove that 1 and 7 are supplementary. Pause the video and complete the packet. Actually, you did need to pause the video because that's all you're getting.